All right, we're back on air, and we have our answers here to problem number 6-69. We're looking at graphing these two equations. So again, we'll walk through the process here step by step. So if you need the help, pay close attention. If you don't need the help, fast forward and just check out the answers. And that should be sufficient. So first steps first, always begin by listing all of your parts. So amplitude of 3. Frequency of pi, shift of left 1, and vertical shift of down 2. Period, well, PV equals 2 pi. So P times pi equals 2 pi, which hopefully logically tells us the period is 2 units. Now, the unique thing here, separate from the previous one we did, is that the period is just 2 units, not 2 radians. So on your x-axis, what are you going to count by? Well, you're not going to count by radians, you're going to count by regular units. I would encourage you to space it out a little bit. So in this case, I'm just going to label each of these bold lines as 1 unit. And same thing going to the left. And we will need to go to the left this time because we do have a left shift. Now, vertically, as far as labeling this graph, we're looking at down 2 and 3 for the amplitude. So if you add those two together, you'll get whatever that maximum or minimum value is. Okay, and that's going to be 5. So we have to have at least 5 units up or down to be able to do this graph. So again, I'm going to make every 2 blocks worth 1. Just to keep things a little spread out. 1, 2, 3, 4, 5. There's 5 in the positive direction. And 5 in the negative direction. Now, once we actually get into this piece of graphing, the first step's always the same. Down 2 and sketch your new x-axis. Second step, still the same. All right, left 1 and sketch your new y-axis. So you sort of have like a new x and y-axis here, which gives us a new origin. That new origin is here. Now, is that going to be a point in the graph? No, not this time, because we're talking about cosine. And cosine, if you remember, cosine goes max, 0, min, 0, max. So again, that's max, 0, min, 0, max for cosine. That's our 5 points of our 5-point graphing method. So our maximum above this original origin here is going to be whatever that stretch factor is, in this case 3. So 1, 2, 3 up will be your first point. I always encourage you to do the same thing. Graph your first and your last points because everything works in halves from there. So if that's my first point, my last point is going to be how far away? 2 units because that's my period. 1, 2. There's my last point. So I have my first and my last point's graphed. My middle point is a minimum. Okay, so halfway between these 2 points here, halfway between them, is going to be that minimum, down 3. And again, it's down 3 from that new x-axis. That's not enough. I know a lot of people here are tempted to make the old V shape. There's a little more curve in it than that. So we got to get these 0 points here, which are going to be halfway between your max and your min. Halfway between your max and your min, and then we're going to draw a nice sketch with lots of curve for cosine. And again, you only need to have 1 cycle of it to get full credit on the test. And that's your graph of cosine. Next, we'll do the graph of sine. I'm going to clear everything out. So if you needed that again, you're going to have to rewind. Let's clear. Oh, I might have cleared page. That wouldn't be good. And it might be too late. That's okay, we can undo this. Assuming my entire system doesn't freeze. Then I'm going to clear just the annotations and start over. So now we have, let's go green. There you go. Same process. Always begins the same. List your parts first. This is worth points on the test. It's like I'm giving points away. Call me Santa Claus. So our amplitude is 2. Our frequency here is 1/3. Our horizontal shift is right pi over 2. and we have no vertical shift. So period, PB equals 2 pi, so P times a third equals 2 pi, which means our period is in radians now. It's actually 6 pi. So this graph's going to be stretched horizontally. So if we need to get all the way to 6 pi to be able to do this, and we do have a horizontal shift of right pi over 2, so really, according to Hank and Lexi, we're going to need 6.5 pi. So we could go, let's see, 2, 4, 6, 8 pi. So let's say 2 pi, 4 pi, 6 pi, 8 pi, and that should get us there. The opposite direction will be negative 2 pi, negative 4 pi, and so forth. New x-axis, we don't have to worry about it because that horizontal axis is going to be at 0. There is no vertical shift. How are we going to label the y-axis? Well, you have 2 and you have no shift, so we can basically pick whatever we want as long as we can get 2 units in. 1, 2, 3, 4, 5. I'm going to go every 5 blocks as 2. Okay, and that'll be negative 2. Here we're talking about sine, so if you forget, sine goes 0, max, 0, min, 0. Okay, and then we begin. So right pi over 2. Whew. Well, if this is 2 pi, and we're looking for a half of a pi, that's going to make this a little tricky. It's probably wasn't good counting here on your x-axis, Mr. Warner. But we're going to have to live with it. So here would be pi, which means pi over 2 is a halfway point. So right pi over 2 is actually going to be right here. And I was not very smart of you, Mr. W, but oh well. Trying to make life easy, cheating as Danny calls it. So there's our first point. Where's our last point going to be? Well, it's going to be 6 pi away. So 6.5 pi, which we already saw, a half a pi is a block and a half. So right there is your last point. Your middle point is going to be between a half a pi and 6.5 pi. So that's 3 pi's away. Okay. So let's see, middle of that and that. So right there's halfway between those halves will be half and half. Right here. Okay. Then we go maximum will be halfway between these halves. Actually turns out to be on a hole, and that's going to be 2 above. Min is going to be here, 2 below. And again, 5 points need to be there, need to be fairly accurate for you to get credit. You may not plug this into a calculator and hit graph and then try your best to sketch what's on the screen. Plus, chances are on a quiz or a test, I'm going to give you numbers here big enough, okay, for your shifts that it won't show up on your standard screen anyway. Just so I can know if you're going to be able to do it. Next we have, let's see, problem 70, but I believe that's a bunch of math notes problems. So you're going to want to copy any of that stuff down into your toolkit. Alright, so you have 5-point reminder, you have general equation for cosine, which is the same as sine, and so forth. So go ahead and copy those things down. Last, we have a situation here. Jenny has a spring with a weight attached that she believes can model using a sine or cosine function. She started a stopwatch and recorded the first high and low points of the weight. The first high point of 46 centimeters above the floor. So 46 centimeters is the maximum. Above the floor was reached when the stopwatch read 0.4 seconds. So that's at 0.4 time. The next low point was 26 centimeters above the floor, so that's 26. Okay, and that reading occurred at 2.2 seconds. And we want to find the, assuming the graph is stretched and shifted sinusoidally wave is shown, copy the sketch, so on and so forth. Use the 5-point method to find the period, amplitude, horizontal shift, vertical shift, that you need to transform the graph of cosine to this graph. Well, let me give you a couple hints here. Some never fails. First of all, let's write what that general equation is so we know all the pieces we have to find. All right, we've got to find an amplitude. We have to find a frequency. We have to find a horizontal shift. We have to find a vertical shift. And we got to know a period. Doesn't matter what order you start in. I will give you an equation for each. Amplitude. Okay, now the amplitude here is pretty simple to find. There is an equation you can use. All you need to do is take your max minus your min divided by 2. And that'll give you the amplitude. So 46 minus 26 divided by 2. So that's going to be 10. B, we already have one. It's PB equals 2 pi. We'll come back to that. H, horizontal shift. Well, if we're using cosine, our horizontal shift here is going to be how many seconds after 0, and that's 0.4 seconds. So you need the picture to be able to do that, and you got to be able to, you have to first choose what trig equation you're going to use. So obviously cosine begins at a maximum. The first point we're given is a maximum. You have to use cosine. K is our vertical shift, and there you're going to average your max and your min. So max plus min divided by 2. So 46 plus 26 divided by 2. Okay, so let's see, that's 23 and 13. So 36 would be their average. And that's obviously up because we're all on 4. Last is period. Well, if we went from a max to a min, to get a full period, we got to go back to a max. Well, how long did this stretch here take us? It took us from 0.4 to 2.2 seconds. So if you subtract those, 2.2 minus 0.4, okay, you're going to get 1.8. And if we double that, because that's a half a period, then we'll get, what, 3.6 seconds for our period. So if the period is 3.6 seconds, that means every 3.6 seconds, the weight on that spring bounces up and down every 3.6 seconds. So once you know the period, then you can find the frequency by plugging that in. So we'll have 3.6 B equals 2 pi. So B equals 2 pi over 3.6. That can be reduced to just B equals pi over 1.8. And then your final step is writing the equation. So you substitute everything that you found here into your equation for cosine. Y equals 10 cosine pi over 1.8 t, and we had a right shift of 0.4, so that's minus 0.4 plus 36. And there you go. That's what we're trying to get to. And we're going to do an entire section on that in the next few days.